Hi, today we're looking at Functional Skills Maths Level 1. This is Pearson Edexcel Past Paper 10, and we're going to start with the non-calculator section. Question 1. Samira reads the results of a holiday survey. We asked 860 people about their holidays. 15% of these people said that Greece was their favourite holiday destination. Samira thinks that more than 100 people said that Greece was their favourite holiday destination. Is she correct? You must show your working. Okay, right. Well, we want to find out what 15% of 860 is, and then we can compare it to this 100 people we've got here. But we haven't got a calculator to use in this question. So what I'm going to do is I'm going to split 15% up and say that 15% is 10%. Plus 5%. And the reason I'm doing that is because to work out 10% of a number, especially when you've got a 0 at the end, is quite straightforward. You just take the 0 off. So 10% of 860 is just 86. Because you're dividing by 10, essentially. So we've got 10%, now we want the 5%. Of 860. Well, 5 is half of 10. So what we want is half of 86. Or 86 divided by 2. Which we can do using the bus stop method. So 2 goes into 8. 2, 4, 6, 8. That's 4 times. And 2 goes into 6. 2, 4, 6. That's 3 times. So 5% of 860 is 43. So 10 plus 5 is 15%. So we just need to add the 86 and the 43. Well, 6 plus 3 is 9. 8 plus 4 is 12. So we've got 129 people. Well, 129 is more than 100 people. So, yes, she is correct. Question 2. Norbert is a doctor. He starts his first shift of the week on Monday at 8 p.m. The shift lasts 12 hours. Norbert then has 30 hours off work. He then starts his second shift of the week. Work out the day and time Norbert starts his second shift of the week. Okay, well, he starts his first shift and it's on Monday at 8 p.m. Well, if it lasts for 12 hours, he's going to end his first shift. Well, 12 hours, the time is still going to be the same, but instead of 8 p.m, it's now going to be the following day. It's going to be 8 a.m. because he's starting in the evening. So it won't be Monday anymore. He's going to finish on the Tuesday. Okay, so this is his 12-hour shift. So we can see that that's 12. Okay. Then he's got 30 hours off work. Okay, well, I know that there's 24 hours in a day. So I know that 30 hours is more than one day. I want to know how much more. So we want to do 30 minus 24. So, well, we can do the 30 minus 24, or we could count up from 24, which is probably quicker, and just say 25, 26, 27, 28, 29, 30. So the difference is going to be 6. Okay, you can do it with the column, you'll get the same answer. Okay, so 30 hours is 1 day and 6 hours. So let's add on 1 day. well, the time will still be 8 a.m. because a full day, but it's going to be the day after Tuesday, which is Wednesday. So we've added on the day. Now we need to add on the extra, this bit, the extra 6 hours. Well, again, instead of trying to do anything clever, we can just start with 8 and add on 6. So it'll be 9, 10, 11, 12. But with clocks, they stop at 12 and they go back round again. So then it'll be 1 o'clock, 2 o'clock. So it's going to be 2 o'clock. It was 8 in the morning, 8 a.m. We've gone past the 12, so it's now going to be 2 p.m. But because it's just gone from morning to afternoon, it's still going to be the same day. So it's going to be Wednesday at 2 p.m. And we can put that down here. Question 3. Here are some numbers. 147, 116, 213, 394, 178 and 312. Work out the range of these numbers. Okay, well the range is the biggest minus the smallest. Okay, well which is the biggest number? The hundreds, this is 200, 300. Well, 394 is bigger than 312, so this is our biggest number. And the smallest, well, 147, 116 is smaller. Anything smaller than 116? No, 116. Okay, so let's write this in a column now. So 4 minus 6, we can't do that because 6 is bigger than 4, so we'll reduce the 9 to 8 and pass the 1 over. So 14 minus 6 gives us 8. 8 minus 1 is 7, and 3 minus 1 is 2. So that's our range, the difference between the smallest number and the biggest number. Part B. Round 4.749 to 1 decimal place. Well, 1 decimal place. The first decimal place is the 7, so we have to look at the digit after that, which is the 4. It's less than a 5, so that means we just leave things as they are. So it's just going to be 4.7. And part C, convert 0.9 kilogram into grams. We need to remember that there's 1,000 grams in a kilogram. So to convert this into grams, grams are smaller, so we're going to have more of them. So we're going to want 0.9 times this 1,000. If we write 0.9 times the 1 means it will stay as a 9. 3 zeros, we want to make the number bigger because we're multiplying. So we're going to move this decimal point 1, 2, 3 times to here. And then fill in the zeros. So we end up with 900 grams. So now we've got, if I just straighten this up nicely. Question 4. Zach is a hotel manager. He knows that 3 out of every 5 guests usually order room service on a Saturday. There are 624 guests staying at the hotel this Saturday. Use estimation to work out the number of guests Zach expects to order room service this Saturday. You must show your working. Okay, estimation. So most of the time, estimation is going to mean rounding. Okay, so instead of 624 guests, we're going to say 624 is approximately equal to 600. Okay, we're just trying to make it a nice round number, nearest 10, nearest 100, whatever works to make the calculation easier. Okay, so we want 3/5 of this because 3 out of every 5 guests. So we want 3/5 of 600. Well, what I'm going to do is I'm going to start off by working out 1/5 sorry, of 600. 1/5 of 600. And that's the same as 600 divided by 5, which we can do using the bus stop method. So 5 goes into 6 once, remainder 1. 5 goes into 10, 5, 10, that's twice. And 5 doesn't go into 0, so it goes into it 0 times. Okay, so 1/5 is 120. We want 3/5. So let's do it below. So that's 1/5. 3/5, we're going to multiply it by 3. 3 times 0 is 0. 3 times 2, 2, 4, 6. And 3 times 1, or 1 times 3, is just 3. So we're going to get an answer of 360. And we can put that in here. Right, now we've got part B. Use a reverse calculation to show a check of your answer. So reverse calculation means starting with your answer and go backwards. Well, we multiplied by 3 to get 360, so we're going to divide by 3 now. Well, if we do this over here, 360 divided by 3, 3 goes into 3 once, 3 goes into 6, 3, 6, that's twice, and 3 goes into 0, 0 times. So 360 divided by 3 equals 120, which is what we had. That's great. Let's go even further back. So we divided the 120 by 5 to get 6. Sorry, we divided by the 600 by 5 to get 120. So if we do it in reverse, we're now going to multiply by 5. So 5 times 0 is 0. 5 times 2, 2, 4, 6, 8, 10. And 5 times 1, or 1 times 5 is 5, plus 1 is 6. So we've gone all the way back to get to the 600 we started with. And that's the end of the non-calculator section. So now let's have a look at the calculator section. Okay, so now we're going to look at the calculator section. Question 1. Inca looks at the performance reports for 2020 from 3 companies. Company A made £750,000 profit. Company B made, and I'm going to put 1, 2, 3, put the comma in there so it's easy to read, made £648,900 profit. And Company C made £725,000 profit. Which company made the most profit in 2020? Show why you think this. Okay, so Company A, how much profit? Well, basically what we're going to do is turn these words into numbers. So 750,000. Right, well 3/4 is 0.75. Yeah, if you're just thinking a standard 3/4. So 750,000 is 750,000. So what you could do, as long as you knew this bit here, the 3/4 was 0.75, you could do 0.75 and then think, well, a million has got 6 zeros. So we're moving this decimal point 1, 2, 3, 4, 5, 6 to here. Fill in the zeros and you'll see £750,000. Okay, Company B, well, they've already told us it's 648,900. And Company C, 725,000. So 725,000, and that's it. 1,000. So just no hundreds, no tens, no units. Which company made the most profit? So which is the biggest? Well, these both start with 700,000, so it's not B. 750 is more than 725, so it's going to be this one here. So, company A. Here are some numbers. We've got 2.89, 2.39, 3.09, 2.41 and 2.9. Write these numbers in order of size. Start with the smallest number. Okay, well, what I'm going to do is I'm going to write them out, but one on top of the other. 2.41 and 2.9. Now, to give them all the same number of decimal places, I'm just going to fill that in with a 0. Okay, well, one of these numbers starts with a 3, the rest start with a 2. So the 3 is going to be the biggest. So actually, let's put that one at the end of the line. Okay, these are all starting with a 2. So basically, we can ignore the 2. We can sort of cover that up, cover it up with a ruler. So we've got 89, 39, 41 and 90. So which is the smallest? 39, then it's 41, then 89, and then 90. So let's write these out. 2.39, 2.41, 2.89, and well, they just had it as 2.9, so we can leave it like that. Now, just quickly going back to part A, obviously we did this nice little thing here, moving the decimal point, but of course this is a calculator section, so we could have just said, well, 3/4, 3 divided by 4, times 1,000,000, which probably would have been an even quicker way of doing it. Question 2. Alex and Seamus played golf. Alex played 90 games of golf last year. She won 60% of these games. Seamus played 80 games of golf last year. He won 55% of these games. Alex thinks that last year she won 12 more games than Seamus did. Is she correct? Well, let's work it out. Let's start with Alex. She played 90 and she won 60%. She won 60 out of 100 times 90. And we get 54 games. Let's do Seamus over here. Okay. He won 55%, so 55 out of 100, of 80 games. And he won 44. Alex thinks she won 12 more than Seamus. Well, 54 minus 44, you can use your calculator, but actually you should be able to see that's just 10. Well, 10 is not equal to 12, so no, she is incorrect. Question 3. Akeem wants to put wooden flooring in a room. He has this sketch of the floor in the room. So we've got some, not all of the measurements, but we've got some of the measurements of the room. Akeem will buy the wooden flooring in packs. Each pack covers an area of 0.4 meters squared. Akeem can cut and join the flooring. Work out the number of packs of wooden flooring Akeem needs to buy. So we need to work out what the total area is first of all, and then we can use this 0.4 for each pack to work out how many packs. Right, so how should we do this? Well, I know that I can work out the area of a rectangle by doing the length times the width. So I'm just going to split this shape into 2 rectangles, and I'm going to do it up there. So this rectangle, it's nice and easy. The area is going to be the length, which is 5.3, times the width, which is 4.3. And we get 22.79. That's meters, and it's squared because it's area. Okay, now we need to do the same for this rectangle. Well, we've got this measurement. We haven't got this one down here. Okay, well, this one is going to be the difference between the full length and just this section here. So we're going to need to do 7.6, which is all the way across, and just subtract the 5.3. So 7.6 minus 5.3, 5.3 gives 2.3 meters. So the area is going to be 2.8 times 2.3. We've already got 2.3 in the calculator, so we can multiply it by 2.8, which gives us 6.44, and that's meters squared. So our total area will be 22.79 plus 6.44. So 6.44 plus 22.79, which gives us 29.23, and that's area still, so we've got meters squared. Okay, if each pack covers an area of 0.4 meters squared, we want to know how many 0.4s fit into 29.23. So we're going to do 29.23 divided by 0.4. And we get 73.075. Well, you can't buy 0.075 of a pack. And if we only buy 73, it's not going to be enough. So we're going to have to buy, well, instead of putting equals, I'm going to say we need 74 packs. Okay, question 4. Jared has part of a map. Okay, so we've got his hostel, we've got a cave, and we've got which way is north on there. Write down the bearing of the cave from the hostel. Remember to show the units. Okay, well, the bearing of the cave from the hostel. So we're starting at the hostel. So this is the important bit. We want to start by looking at north. And then we want to go round in a clockwise direction until we meet the line that's going to the cave. Okay, so this is the angle we want to work out. Right, so I'm going to get my protractor. Because we're starting up here, I'm going to turn my protractor this way. Get it on the crosshairs there. So I'm starting at 0. And I'm going to follow this. Let's line that up properly. 0, 10, 20, 30, 40, all the way around until I find this line coming across here, which is halfway between 90 and 100. So this is going to be 95. So the angle is 95 degrees. When we write a bearing, we tend to write a bearing in 3 digits. So we can put it as 0.95 degrees. When they're talking about, remember to show the units, that's what they're talking about, the little degree sign. Jared goes to the cave on Friday. He knows that the probability of sunny weather on Friday is 7/10. Mark this probability with a cross X on the scale below. Well, we've got 0 and we've got 1. So let's see how many sections we've got here. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, so splitting them all into tenths, we want 7/10. So 1, 2, 3, 4, 5, 6, 7 is going to go there. Question 5. Jesse is the head of sport at a college. He has data about the number of students studying sport for the 5 academic years. So for the academic year 15-16, so that means 2015 to 2016, there were 34 students. 2016 to 2017, there were 46, and so on. Jessie will show this data in a bar chart at a staff conference. Draw a suitable bar chart for Jessie. Right, okay, and we've got our graph paper down here. And we've got 1, 2, 3, 4, 5 groups. And looking at this, we've got 1, 2, 3, 4, 5 of these big squares. So I'm going to start off by marking these on. And so these are going to be the academic year. So we're just copying what they gave us above. So this was 15-16, 16-17, 17-18, 18-19, and 19-20. Yeah, just copying it from the table. Right, now this is the bit that we need to a little bit more thinking about. We've got the number of students, so that's going to go up this side here, number of students. What's the biggest number? Because we're going to make sure at least the biggest one fits on. Well, 98 is the biggest. Okay, so looking at this here, we could say, all right, we could just say, well, 10, 20, 30, 40, 50, 60, 70. Oh no, we don't want to do that because we're going to run out if we keep doing that. So what we can say instead is, well, how can we break this down? Well, instead of each of these being worth 10, because it's not going to fit, what about if we say each of these is worth 20? So that would be 20, 40, 60, 80, 100. Well, that's fine. We want to go up to 98, so going up to 100 would be fine. And remember, when you're writing the values in on here, you don't have to write all the values. You can skip some out like I've done. I've gone up in 20s. It's absolutely fine. Right, so the first one, first academic year, we've got 34 students. Well, 30 would be halfway between 20 and 40. Now, we've got to work out, we don't want to count out 1, 2, 3, 4. That's going to be too big. We've got to think, well, if this is 30, we've got 5 boxes, but we've got 10. So we must be going up in 2s each time. So 32, 34, 36, 38, 40. So 34 is going to be that one there. And then for the next academic year, we've got 46. So we're up to 40. And again, we're counting 2s. So 42, 44, 46. Draw across here. The next academic year, let's show you 17 to 18. There were 82 students. Well, that's 80s here. 82 is going to be one line up because we're counting in 2s again. 18 to 19 was 98. Well, we could count up, but if you think 98 is just 2 less than 100. So we can mark it on. And 19 to 20 was 70, so halfway between 60 and 80. Right, and now I can draw in all my lines. Now for a bar chart, you don't have to have the bars touching. I do because it's easier. I don't have to draw so many lines. And then we just need a title. We can put sports numbers. That's going to be fine. Okay, we've got all our values, we've got our labels, same at the bottom. Question 6. Zelda works in a spa. She takes care of the swimming pool. The swimming pool is in the shape of a cuboid. The water level in the swimming pool is 0.3 metres below the top of the pool. Okay, so we've got our measurements here. So it's 1.8 metres all the way up, but 0.3 metres hasn't got any water. Zelda knows 1 metre cubed equals 1,000 litres. She needs to put chlorine powder in the water. Zelda uses this rule to work out how much chlorine powder she needs. So she takes the volume of water in litres, divides it by 5,000, multiplies by 56, and it gives her the chlorine powder needed in grams. And they're asking us to work out how much chlorine powder Zelda needs to put in the water. Right. Well, to use this formula, we need to know the volume of water. And the volume is the length times the width times the depth or the height. Okay, basically the 3 different dimensions of the cuboid. Right, well, the length, well, that's going to be this length here, so it's going to be 20 metres. The width is going to be this direction here, it's 10. And the depth of the height, well, we've got to be careful because 1.8 metres is the whole lot, but we don't want that little bit there. We don't want the 0.3. We want just the water, which is going to be 1.8 minus the 0.3. Which gives us 1.5 metres. So if we multiply these all together, 20 times 10 times 1.5, we get 300, and that is metres cubed. Okay, right, that's metres cubed, but they wanted the volume of water in litres. So we've got to use this conversion. 1 metre cubed is 1,000 litres, so we've got to multiply this by 1,000 to get everything into litres. So 300 times 1,000 is going to give us 300,000 litres. So now we can put it in the formula. So we've already got the 300,000 there. We just need to divide it by 5,000. And actually I'm just going to write 60 so we know that's what we get at this stage. Then we multiply it by 56, which gives us 3,060. And that tells us the chlorine powder needed in grams. So it's just this answer here, 3,360 G for grams. Question 7. Tom looks at a map. 1 centimetre on the map represents 3 kilometres on the ground. The distance between 2 cities on the map is 5 centimetres. Work out the actual distance between the 2 cities. Well, if 1 centimetre is 3 kilometres, 5 centimetres, well, it's 5 times as big, so it's going to be 5 times 3, which is 50. You can use your calculator, but you probably don't need to do that. In part B, how many lines of symmetry does a square have? Okay, well, I'm going to do a quick sketch of a square. Doesn't have to be precise, but I know that we've got a line down the middle vertically. We've got a line across horizontally. We've also got one diagonally that way, and I'm going to use my ruler because I'll get it wrong otherwise, or it won't look as clear. We can have another one that way. So in total, we've got 4 lines of symmetry. If it was a rectangle, we'd only have 2. We wouldn't have the diagonal ones as well. Okay. Here is the front elevation of a building. What is the greatest height of the building? So front elevation, so we're looking at it there. So this is the ground floor. This is the top. So it's going to be 27.4 metres. Nice and straightforward. Question 8. Maya designs a flower bed. She has this sketch of the flower bed. So we've got a triangle there. We've got the measurements on 3 sides. Maya will put an edging along each side of the flower bed. Work out the total length of the edging Maya needs. So we're just going to add them up. We're going to have 180 plus 215 plus 120 because they're the same units. So we can just add those. 180 plus 215 plus 120. It's just going to be 515 centimetres. And we check, they've given us the units, yeah, they want it in centimetres, so that's fine. Don't need to do any converting. Right. Now they've asked us to show a check of your answer. Well, we can do a reverse check. So we can start with the answer 515, and we added everything together, so we'll take them off. We'll minus 120, and then we'll minus 215. And if we have done it correctly, then that should take us back to what we started with, which was 180, which it does. Question 9. Tim makes sandwiches in a cafe. The sandwiches can only be sold on the day they are made. The table shows the number of sandwiches Tim did not sell last week. So Monday he had 15 he didn't sell, Tuesday there were 26, and so on. The cost of making each sandwich is £1.95p. Tim thinks the mean cost of making the sandwiches he did not sell last week was more than £25 per day. Is he correct? Show why you think this. Well, let's work out the mean, and then that will be the mean number of sandwiches. We can multiply it by the £1.95 and compare that cost to the £25 a day that he thinks it was, or he thinks it was more than. Okay, so the mean is the total divided by the frequency, or how many. Well, the total is going to be 15 plus 26 plus 9 plus 11 plus 20 plus 16 plus 1. So 98. And how many? Well, it's going to be how many days? 1, 2, 3, 4, 5, 6, 7. Which is 14. So that's 14 sandwiches. Well, 14 sandwiches at £1.95 each means that the cost is 27.3. Well, because it's money, that's going to be £27.30. Well, that is more than £25. So is he correct? Yes. He is correct. Question 10. Colin has this data about the number of treadmills in several gyms. Okay, so one gym's got 7 treadmills, one's got 11, one's got 5. Colin begins to design a grouped frequency table to show this data. He will use 3 groups of equal size. Complete the grouped frequency table for Colin. Okay, well, let's do the groups first of all. They said they're equal size. Well, if this is 1 to 5, that means it includes 1, 2, 3, 4, 5. Okay, well, the next group must start with 6. And there were 5 in the first one, so 6, 7, 8, 9, 10. So it's going to go up to 10, which means the next group's going to start at 11 and be 11, 12, 13, 14, 15. Right, so there's our groups. Okay, well, let's see. How many are there between 1 and 5? Well, 1, 2. So that was just 2. How many between 6 and 10? 1, 2, 3, 4. So 1, 2, 3, 4. And how many between 11 and 15? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, there we go. Now, I did it by counting how many in each group. What you could do instead is start with the 6 and then put a mark, and then the 11 and put a mark down here and 5. It doesn't matter which way round you do it. I find it tends to be quicker to do it per group, but just make sure that you cross them off so that then you can also see that there's none left unallocated at the end as well. Okay, and finally we've got question 11. Ashley wants to buy a wall clock. She finds these two offers. Offer A, wall clock. Normal price is £31.80. Now 45% off the normal price. And offer B, we've got a wall clock. The normal price is £34.50. Now half price. Ashley thinks she will save less than 50p if she uses offer B rather than offer A. Is Ashley correct? Show why you think this. Okay, so let's start with offer A. So £31.80, 45% off the normal price. So let's work out what 45% is and then take it away from the original. So 45%, so 45 out of 100, of always means times, so times £31.80. To over here, 45 over 100 times £31.80 gives us £14.31. And then we want to take that away from the original, so £31.80 minus £14.31. Gives us £17.49. Offer B is half price, so we want a half of £34.50. Or we could have done £34.50 divided by 2. And that gives us £17.25. Okay, she was talking about how much we'd save. Well, let's work out this. She says she'll save less than 50p if she uses offer B. Well, offer B certainly is cheaper, but let's find out how much cheaper. £17.49 minus £17.25. And we get £0.24, which is 24p. Okay. Well, 24 is less than 50, so yes, she is correct. Well, Ashley could be a man, could be a woman. Either way, they're right. And that's the end of the paper. So I hope you found it helpful. Please like the video, subscribe to the channel, have your notifications turned on to find out when I add more videos, and I look forward to seeing you again soon. Thank you.